Hello and welcome to Focus on Concepts. In this week's weekly dose, we bring to you why shaving mirrors are slightly concave. Slightly is the key. Why shaving mirrors are slightly concave. Well, before we get to the problem and the solution, let us understand something about problems and solutions. Well, hungry. Everybody gets hungry, whether a toddler or an adult. So that's a problem. To get hungry is a problem. Why do we get hungry? Well, a toddler doesn't know about it and he just cries, just yells. For us adults, we know why we are hungry. Well, I had my breakfast at 6 a.m. this morning. It's 4 p.m. and I have not had anything ever since I had my breakfast. It's been a long, long time I had something, and that's why I'm hungry. So I know why this problem is occurring, unlike a toddler who just cries. Now, if I know the solution, if I know why this problem is occurring, I am better placed to find a solution. Am I not? A toddler doesn't know what the solution is because he has not even understood the problem. As for adult, we know what the problem is, why it is occurring, and therefore we know what the solution is, and we all know what to do. We grab something, don't eat junk food, as they say. Well, we must grab something, we must eat something to quell that hunger, and that's the solution. So, overall, this is a three-stage thing. The problem, everybody experiences this, irrespective of whether we are knowledgeable or we are not. But if we are knowledgeable about the problem, we understand why it is happening, and that leads us to finding a solution. Yes, so this much philosophy about hungry and toddler and adults. Let us now understand concave mirrors. What are concave mirrors? Concave mirrors are mirrors having spherical surfaces, and these spherical surfaces are part of a sphere that determines its radius, that determines its focal length. Well, it's part of a sphere. Well, a marble, the concha that we used to play. Maybe I don't know if you people did. I did. The smiley ball, a football, a globe. These are all spheres, are they not? They're all spheres, but of different dimensions. They are spheres of different radii. So also the reflecting surface of a concave mirror. It can be as small as this. If I extend this, you see that this is the size of the sphere of which this reflecting surface is a part. And this curvature, as we say, is pretty high. Its curvature is high because it forms a very small sphere. And here, this being the center of this particular sphere, CP, as we know, CP is called the radius of curvature. Half of it is the focal length. In this case, FP is the focal length. The same concept now over to a larger mirror. So in this case, you see that this is again a curved surface, but it forms a part of a large sphere, and therefore the radius of curvature, this is the center of curvature, so radius of curvature of this particular mirror is way higher than the radius of curvature for this. Half of this being the focal length, we know that this particular distance between the focus and the pole is considerable, is reasonably more. Now, one thing that we must also know, that's a prerequisite for this particular session, is that for a concave mirror, if an object is placed in between the focus and the pole, the focus and the pole, the focus and the pole, only then we get a virtual image which is enlarged, and erect. Every other position of the object will only get us virtual images on screens, and they're all inverted. Let's not get into the real images and the inverted images. We're only talking about virtual images formed by concave mirrors, and they are formed only when the object is placed in between the focus and the pole. The focus and the pole. The object must be placed in between the focus and the pole. Well, now comes slightly concave. Slightly. What is the significance of this word or this term slightly here? That's very important. Shaving mirrors are concave. That's just as good as nothing. Shaving mirrors are slightly concave. That's the key. Slightly is the key here. And this has been a classic question. It's been coming in the boards for decades now. For decades. Classic question, as I said. So in this case, look, we have already understood that the object must be placed in between the focus and the pole. Now, if this distance is as little as we have here, how are we even going to place our face there in the very little distance that we have? This in itself is very little, and the object distance has to be lesser than the focal length. Focal length is what? FP. FP is the focal length. So this in itself is just in centimeters. And now the object distance ought to be even less than it for a virtual erect enlarged image to be formed. How are we going to squeeze our face in that very little space? We can't. And even if we manage to, we have very little distance between the mirror and our face. There is a minimal distance we must have to be able to see the images properly. And this is where this mirror helps. As you can see, this is only slightly concave. This is highly concave. This is only slightly concave. And as a result, there is considerable distance between the pole and the focus. And therefore, we are better placed. We are better placed to place our face in this distance. There is quite some margin unlike this. And this is how we place our face anywhere in between this. There's considerable margin, as I said. And the result is that we are satisfying the prerequisite for the concave mirror's virtual image. What is that? The prerequisite is that the object must be placed in between the pole and the focus. We do that. We are doing that even here. But this is not a very good arrangement, not a very comfortable arrangement. This one is. So now putting all the dots together, why are shaving mirrors slightly concave? Hey, this is slightly concave. This one is way too concave. And it's only when it is slightly concave that it forms a part of a large sphere, because of which it has a considerably high radius of curvature and consequently the focal length. Now if we place the object in between the pole and the focus, we get an enlarged clear image, and that helps us. That's what a shaving mirror must have. It must give us an enlarged erect image. Now just comparing this with the earlier philosophy that we heard. Well, in this case, the problem was feeling hungry. Anyone can feel hungry. So in this case, if you place yourself or your face in front of a concave mirror, and if the concave mirror is considerably far away from you, you won't even get to see your image. You won't even get to see your image. So this is a problem that anyone can face. Anyone can face. I, who know about this problem, or somebody who does not even know about this problem, if I place my face reasonably far from the concave mirror, then I wouldn't get a virtual erect image. It will be all hazy. So this is a problem. Now comes somebody who understands the problem. So he knows, hey, this is happening because the object is way beyond the focal length. It's because beyond the focus, sorry. If the object is way beyond the focus, you won't get a virtual image. So I know, because of my knowledge about concave mirror, I would be in a position to know why this is happening, why the image is not erect, and why am I not able to use this concave mirror as a shaving mirror. So that's now the understanding of the problem. What is the solution? I bring my face nearer to the mirror, or I bring the mirror nearer to my face. That's the third part. So I experience the problem, I know why the problem is occurring, and that leads me to finding the solution. And that explains why shaving mirrors are slightly concave, highly concave, slightly concave, highly concave. Highly concave is part of a very small sphere, and therefore there is very little space between the pole and the focus. If it is slightly concave, as is the case here, it has a large radius of curvature and consequently the focal length, and there is considerable margin, the space is considerable for me to place my face there. That's why shaving mirrors are slightly concave. Thanks for watching.